Hello students, my name is Manpreet Singh. I've done my MTech, that is Masters of Technology from IIT Guwahati in 2012, right? And I have worked at a lot of different centers, rank producing centers like Akash Institute, Vidya Mandir classes, and obviously the most famous one these days, Physics Wala. Currently, I am associated with Unacademy Center Computer, and we are planning here, we are giving our best. This year also, we are going to give some decent NEET ranks. Okay, also we are having JEE batches as well. So this is one of the last year rank. When we know that the NEET exam was very tough, 2025, I got one of my students scoring 1353 rank, and he is currently at AIIMS Patna pursuing medical, that is MBBS, right? Okay, so we will discuss some very small topic here, okay, to understand the concept. So let's start from the beginning. I am going to start from the first chapter itself. Okay, so let's start. We are going to discuss motion in one dimension. So what do you exactly mean by motion in one dimension, motion in two dimension, motion in three dimension? What does it exactly mean? So you already know the coordinate system, right? We take this as an origin. You have already discussed in your junior classes, 8th and 9th mathematics. This we consider as an x-axis. This is what we consider as an y-axis. This is what we consider as a z-axis. Now in this case, if the body, if only single coordinate of the body is changing, that is called one dimension. For example, I take a body, it is moving on x-axis only, like this. Understood? If it is moving on x-axis only, that case I can say that it is performing what? Motion in 1D. Okay, it is performing what? 1D motion. Understood? Now if I consider the same body moving on xy plane, if the same body is moving on what? XY plane. So how it will be moving? Let's consider same body. Okay. And let's consider another body. If this body is moving in some direction like this on, I will consider on XY plane. Then how many coordinates will be changing? Its X coordinate will be changing, its Y coordinate will be changing. So in that case, I can say that it is performing what kind of motion? 2D motion. Understood? Now, if the same body is moving in such a way that its x, y and z, all three coordinates are changing, that is called 3D motion. But here we are going to discuss motion in one dimension. So body will be moving in positive x direction or maybe in negative x direction. So body will be moving on this particular axis, or we can consider that body will be moving along y axis minus y axis, or maybe along z-axis minus z-axis. Okay, so that motion in which only one coordinate is changing, that is called motion in one dimension. Clear? Let's move ahead. Translatory motion. Now in this case we talk what? Translatory motion. What is translatory motion? So there is a very simple definition to make it to make this concept understandable to all the students. What is translatory motion? Motion in which all particles, or I would say all points of a body perform, or you can say all the points or all the particles or points of a body cover equal distance in equal time. Okay, like that. So that is called translatory motion. So he will take one body, he will take 2 points, and we will see how it performs translatory motion. But now there are two parts. Translatory motion has two parts. One is called rectilinear. One is called rectilinear motion. And other kind of translatory motion is called what? Curvilinear. It is called what? Curvilinear. Okay. Now what do you exactly mean by rectilinear? Try to understand. For example, I take a body here like this. It is having one point A and other point B. Okay. Now this body is moving like this. It from this point to this point, it moves on a straight path. So how it will be moving? Let's consider the body reached here, and this is your A point. So A moved like this and B also moved like this. Now try to understand, both covered same distance in same time. So this is called rectilinear motion. This is called what? Rectilinear motion. Okay, understood? That is rectilinear. What is curvilinear then? If this is rectilinear and this is a part of translatory motion, then what is curvilinear? Curvilinear is that you take a body, again you take the 2 points A and B, and it moves in curve. The body moves like this. So in that case, A point will go like this, and also B point will be going like this. So A and B point of a body reached here and the body is here. Understood? So this is also a kind of, not try to understand, A distance covered by A and the distance covered by B is same in same time, as you can see from the diagram itself. So this is called what? Curvilinear motion. This is called what? Curvilinear motion. In simple words, we can say if the body is not rotating, if the body is not rotating like this, then that kind of motion in general will be translatory motion. And these are the two parts. Which one we generally discuss at the starting? This one. Rectilinear motion we discuss. Okay. Now moving ahead, rest and motion. What do you exactly mean by, the body is at rest or the body is in motion? Okay. Now, first we can understand rest. When body does not change its position with respect to observer, or we also call it what? Reference frame. Okay, let's consider a reference frame as coordinate axis like this: x, y and z. Okay, and this is your region. For example, as an observer, you are standing here and you see a body is kept at which coordinate? 2, 2. So this will become what? 2, 2. Understood? Now you see, even at any time, this body is not moving away from this particular person or moving toward this person. So the separation of that body from the observer is not increasing or decreasing. So that in that case we say that body is at rest. Understood? So this body I can say, is it at rest? Okay, with respect to the observer or with respect to this reference frame which I have taken as a coordinate axis, x-axis, y-axis, z-axis. Understood? Its coordinate is not changing. That is another definition we can take, that its coordinate is 2, 2, that these coordinates are not changing at all. So in that case I can say that this body is at rest. Okay, so what do you exactly mean by body in motion? Just opposite of rest. Understood? When body changes its position, when body changes its position with respect to what? With respect to observer or reference frame. Okay, so when the body is changing, for example, you are taking a body here. Okay, so there is one body here and it is moving in a particular direction. Okay, like this, like this, like this, with some particular speed or something, it is moving. So it is increasing or maybe decreasing its separation from the observer or from the origin. So in that case we can say when the body changes its position, its coordinate axis would be changing, x coordinate, y coordinate, z coordinate, these coordinates will be changing. Got it? So this body we can call that it is in motion. So body in rest and body in motion, that is basically related to the reference frame. I will tell you how. It is all relative. Right now I am standing here. Am I rest or not? Yes, rest. But when you observe me, when you observe this person from the space, I am rotating with earth. Understood? So it is all relative. It depends upon what kind of reference frame as an observer you are standing in and observing another body. So a body can be at rest from one frame and the body can be in motion from the another frame. Understood? Okay. Now moving ahead, trajectory equation. What is the trajectory equation? Equation relating coordinates of a moving body. Okay, that equation is called what? Trajectory equation. Try to understand. For example, if I take this as a y-axis and I take this as an x-axis. Okay, now a body is moving on this path at what angle? 45 degree. Got it? So the body is moving on this particular plane at an angle of 45 degree. So what is the equation of this line? Can you tell me? We will discuss that in basic mathematics. I will tell you right now. The equation is y equal to x. Okay. So this is the trajectory equation of this body, because after some time body is here, at some time body is here. So it is following this trajectory equation. Understood? So that is called what? Trajectory equation. It is not necessary that only two coordinates are there. This equation may be involving x coordinate, y coordinate and z coordinate as well. If the body is moving in 3D, here the body is moving in 2D. So only two coordinates, two variables are there. Okay. So it's like that. Now moving ahead, main topic, displacement and distance. That is what I have written? Absolutely. So what do you exactly mean by distance and displacement? Okay. First we will discuss distance. Distance is what? Distance is total path length traveled from initial to final position. Okay, try to understand what do you exactly mean by distance. Total path length traveled from initial to final position. I have taken one diagram for reference. Okay, now in this case I am taking this as the initial. This is a kind of home, and from this home I am going to another home. Understood? So this is my final position. Okay, so this is initial, this is final. Got it? And I am going through this path. I am moving through this path like this, going like this, like this, like this, like this, like this. Understood? So in this case, what is the distance? I will measure this. Okay, so it will be like this, 1 meter, then this will be 1 meter, then this will be 1 meter, then this small path will be 1 meter. Understood? So I will add all of them. Let's consider after adding all of them, I am getting 40 meter. Okay. So distance is nothing but this path. You add the entire length of this path. That is called what? Distance. Okay. So that is total path length travel from initial to final position. Got it? For example, we are getting here 40 meters. So distance is how much? 40 meter. Okay. Now also, what are the other properties? Unit will be what? Simple. Unit is going to be what? We take what SI unit for the length, we take meter. So it is going to be meter, that is M. After this, we will be discussing what kind of quantity is it, scalar or vector. Scalar quantity is the quantity which has only magnitude, that is a value and unit. Vector quantity is which is having magnitude, unit as well as the particular direction. Understood? So distance is what? We are having this path. So there is no one single specific direction. Understood? So that's why it is a scalar quantity. Okay, it is what? It is a scalar quantity. Now another concept is for fixed initial and final position, there can be infinite number of distances. Okay, how we can understand that? See, I have taken this path, so the answer is 40 meter. If I take this path, answer will be lesser than this. That let's consider it will be, for example, 30 meter. So you from initial to final point, you can go like this, you can go like this, you can go like this, you can go like this. Okay. So there can be number of distances from particular initial position to particular final position. Understood? Okay. So there can be. Now also one more thing. it is a positive quantity. It is a positive quantity. Whenever I'm writing 40 meter, 30 meter, okay. So this 40 meter, 30 meter, this is going to be what? Always a positive value. Understood? So that is what? That is your distance. Now the point is, this is all about distance. What do you exactly mean by displacement? They both look very similar, but they both are very different kind of quantities. Displacement is nothing, it is called shortest path length. It doesn't matter which path you are following. You follow this path, you follow this path, it doesn't matter. What is the shortest path? This is the shortest path. Understood? Already written here. This is the shortest path from initial to final. Let's consider this length is 20 meter. Okay, got it? So in this case, how much is the displacement? 20 meter. Understood? So now what are the different things? I will compare same. So unit, it is also having how much unit? Which unit? Obviously it is also a length. So unit is going to be meter. Okay, it is a scalar quantity. In this case, it is not a scalar quantity. In we will study vectors, and you will see in vector there is one arrow having tail and head. So we will keep that vector like this, tail here and head here. So there will be one length vector having how much length? 20 meter in scale. Okay, so it is what? It is a vector quantity. Okay, also as we have discussed, for fixed INF there can be infinite number of distances. For fixed initial and final position, for fixed initial and final position, there is only one displacement. Okay, displacement, or I can write there is only one displacement vector. Okay, this one only, straight. So if initial is fixed, final fixed, single displacement vector. Okay, it is like this. And also it can be positive or negative or even 0. Now try to understand, in case of distance, we can say for moving body, a body is moving, distance can't be equal to 0. Understood? It doesn't matter if the body is moving here or even if it is coming back, it covers some distance. A moving body covers some distance. But what about displacement? Now they are saying displacement can be positive. Okay, displacement can be positive. How? Let's consider this is your x-axis and this is origin, and this is minus x-axis. Understood? And this is origin, where the x coordinate is how much? X equal to 0. Got it? If the body's net displacement is in negative direction like this, that initially the body is here and finally the body is here. So this is what? Negative displacement. Okay. If initially the body is here and finally the body is here, then this is called positive displacement. Understood? So displacement can be positive or negative depending upon the situation. When the displacement is 0, when body starts from here, moving here and there and coming back to the same position, just like you leave your home in the morning, go to school, go to tuition classes, coaching classes, and you come back to your home. So what is your displacement? 0. Understood? So displacement can be 0 for the moving bodies. That's why I've written 0. So it's like if you start from here, moving like this and coming back to the same position. In this case, displacement is what? 0. Understood? So this is the difference between distance and displacement. This is the difference between what? Distance and displacement. Okay, just main points. Okay, we can try to solve some questions now. Let's see. Yeah, here we can understand. I have taken x-axis. Okay, so this you can consider as an x-axis, and these are the positions. What is the position here? X equal to -1. What is the position here? X equal to 3. What is the position here? X equal to 5. Got it? Now in this case, for example, I will consider initially the body is here. Then body moved to this location, and from here x equal to 0, body moved to 9 position. Got it like this. So what is going to be the distance? What is going to be the displacement? So I will write first distance in this case. So distance is going to be how much? Let's see. From 5 to 0, how much it covered? 5 meter. I am considering the scale in meter, okay? The scaling is what? It is in meter. So body moves from this point to this point, how much? 5 meter. Then from 0 to 9 it moves. So it will be how much? 9 plus 5, that will become how much? 14 meter. That is your distance. Understood? Now how to find the displacement? See, this is initial position, body reached here, then it is reaching here. This is the final position. Understood? So try to understand, just by looking at the diagram, body just displaced from this position to this position. So what is its net displacement? This one. This is its net displacement. I am, dark, making it dark. So this is the net displacement. How you can find the displacement in this case? You write final position minus initial position. So what is the final position? 9. What is the initial position? 5. So how much is the displacement? 4 meter. Understood? This is how you find distance and displacement. For distance, I added all the paths. For displacement, only this straight path I am finding. Understood? Yeah, body can have negative displacement as well. Let's consider body is here initially and body moved to this position, minus 7. So what is going to be the distance in this case? Distance is going to be how much it moved. From 0 to minus 7, it moved 7 meter. Distance is always positive. So I am writing 7 meter. So in this case, the distance is 7 meter. What is going to be the displacement? Displacement is going to be final position minus 7 minus initial position 0. So displacement is going to be what? Minus 7 meter. So you can see that displacement can be negative as well. Understood? Now, zero displacement you want. Let's take one example. Body started from here, reached this position, that is 4, and then came back to this position. So this is also its initial position, this is final position. How much distance it covered in this case? Distance is going to be, let's check it quickly because it's a simple question. It moved 4 and then it moved 4 back. So distance is going to be 8 meter. Displacement is going to be 0 in this case because it is at the same position. Got it? So this is how we can solve simple questions of distance and displacement. Now moving ahead. This is a summary. Okay, we have already discussed it. We will summarize in 1 minute. Distance is the actual length of the path traveled by the object in a given time interval. It is the shortest distance between the final and initial position of the object in a given time interval. It's a scalar quantity, it's a vector quantity. There can be many paths between two positions, so distance can be. So the values of the distance traveled by an object in a given time between the two positions, it can have different values. But displacement is, it is always same. From initial to final, there is only single value of displacement. The value of distance can only be positive, displacement can be 0, negative or positive. We have already understood that with the help of numericals. Okay. Now, in this case, they are saying that this fifth part is distance is always going to be greater than or equal to the magnitude of displacement. This is I am taking mode, which you discuss it in mathematics, right? That is a positive value. We are just taking the magnitude of displacement here. See, if the body is having unidirectional, straight line motion like this, the body is moving in a single direction and it reaches here. So in this case, distance is going to be equal to the magnitude of displacement. Understood? Any other case, other case will be body is going like this, then coming back, then going. Any other case, distance is going to be greater than, distance is going to be greater than the magnitude of displacement. Understood? So distance is going to be greater than the magnitude of displacement in any other case. Understood? Now moving ahead, there is one numerical. So let's try this numerical. Now in this numerical, they are saying a man moves along a path A, B, C, D, E like this. You have to find the displacement. So I will change the color. Yellow color is maybe not be visible here. So let's see. Let me take some dark color. I will take the red color. Okay. So let's see. Yeah. So now in this case, a body initial position is A, body final position is E. Okay. So if I try to write the displacement, what is the displacement? This is the displacement vector. Understood? This is the displacement vector. I have to find this length. Okay. Now how to find it? First of all, what I can do for this part, I can apply the Pythagoras. I have to find this length and I have to find this length. Understood? These two lengths I have to find. So how to do it? See, I can resolve. If you study vector, you will see that this 4 I can resolve into two components. This length will become 4 cos 60 and this length will become 4 sin 60. Got it, students? So this length is 4 sin 60. This length is this length from here, this length only. That is 4 cos 60. Understood? Now in this case, what this length will become? First of all, let's calculate. 4 sin 60 will be how much? 4 sin 60 will be 4 into root 3 by 2 into 2 root 3. 4 cos 60 will be how much? That is 4 by 2. That will become what? 2. Okay. Clear? So 4 cos 60. Got it? So this is what? This is your 4 cos 60. That will be how much? 2. So this length is 2. And this length is how much? 2 root 3. So what this will become? Try to understand. This is 2 root 3. This is 1. So this will become 2 root 3 minus 1. This is not 13. Okay. This is 2 root 3. So 2 root 3 minus 1. This length. How much will be this length? 2. See, total is 8. Okay. Total is 8. Okay, students. I have to minus this part. From total, I have to minus this part. So I will do it here. It will be 8 minus this part, 2 minus this part. How much? 2. Understood? Getting it? So from total, I am subtracting this part and this part. So how much it will be? 4. So this length is nothing but 4. Now I can apply Pythagoras. Displacement is going to be how much? 4 square plus 2 root 3 minus 1 square. Yes, we are not going to get very single numerical. We will be getting something in decimal. But for the explanation part, I have taken this question. Okay. So you can do the square, you can write whatever is there. Okay. You can solve it further. Got it? We will solve it. 16 plus square of this. How much it will become? A square plus b square minus 2ab. So square of this will be 12. Plus square of this will be 1. Minus 2 into this will become 4 root 3. Understood? So this will be 16 plus 13. It will be how much? 29 minus 4 root 3. Okay. So that is your final answer. Let's solve some more good questions. This one, this question you will see everywhere in distance and displacement, every module, every book, you will see this question. So let's see what the question is. Find distance and displacement when the body moves from A to B. Body is moving on the circular path. So let's consider it is having how much radius? R. Okay, it is having how much radius? R. So first condition A to B, A to C and A to D. So he will solve the first part here. On this screen, we will be solving the first part. When the body moves from A to B on this path. Understood? Like this. It is reaching here. Find distance and displacement. How much is the total circumference of a circle? 2 into pi into r. That is clear. How much is this part? This is the distance. This is nothing but the distance. How much is this? This is nothing 1/4. Understood? This is nothing but 1/4. So can I write distance here? I will write distance covered in this case is 1/4 of 2 pi r. Got it? So it will become what? Pi r divided by 2. That is very easy to find. Got it? What is the displacement? That is not the displacement, that is the distance. Displacement means shortest path. So this is the shortest path. Okay. How much is the length of this? See, you can take the center somewhere here. So this length will become what? R. This length will become also R. If I apply the Pythagoras theorem, this is R, this is R. So this length will become what? R root 2. So I can write confidently displacement is going to be how much? R root 2 when the body moved from this A to B on this particular path. Got it, students? Okay, so this is how it is. Now, first part we have solved. Let's discuss second part. In second case, they are saying body is moving from A to C. So body is here. It is moving like this. Body is moving from A to C like this. If the body is moving from A to C, how much will be this distance? This is the distance, right? This is going to be the distance. This is nothing but half of the total circumference. Understood? So I can write distance here. Distance is going to be how much? Half of 2 pi r. Got it? Half of 2 pi r. So this will become what? Pi r. That is your distance. What about displacement? It is having radius r, capital R radius we are considering for this path as well, obviously. Now in this case, this is going to be the displacement. This is a line diameter. This is nothing but the diameter passing through the center. So this is the displacement. So displacement is going to be how much? Displacement is going to be r plus this r. So this will be your displacement, that is 2r. Got it, students? That is the second part. Now moving from A to D. Let's see. Now third part we are going to solve, that is body is moving from A to D. So when the body is moving from A to D, it will be moving like this. It will be moving like this. It is reaching here. Understood? In this case, this total length will be what? 75% or 3/4. Understood? 3/4 of the total circumference. So how I can write distance in this case? Distance is going to be 3/4 of 2 pi r. Okay. So this will become 3/2 pi r. Okay. So this is 3/2 pi r. Got it? So now in this case, if I am taking this r and r, what about this displacement? This is the displacement. So body moved from A to D. This is the displacement. This is the kind of, I can draw displacement vector having its tail here and head here. So what is this length? Again the same way. This is what? This is your r, and this is also r. So this will become by Pythagoras root 2r. So this is your displacement in this case. Understood? So that is all about distance and displacement. Now we are moving to a very good question, a very tough question, not the simple questions like this, a very tough question. So we will try to understand how we can solve the question. Okay, please check. Yeah, you would have played this Carrom, the square wooden board, 4 holes on the corner, and there is one key striker which you strike like this, right? So this question is entirely based on that. So there is one striker key. Okay, let's consider it is having red color like this, and I strike it like this. Okay, so it goes here, it reflects from this corner, then it is going here and it enters this hole. Understood? Got it? Let's consider side of this particular Carrom board is given small d. So this is also small d, this is also small d. Understood? They are asking find distance traveled by the striker. Displacement is easy to find in this case. This is the displacement. Okay, that is easy to find. Find the distance. So what can I do? There is a symmetry here. See, this angle and this angle is equal. Okay, understood? Okay, now these angles are equal, and you can understand here If I take three triangles here, try to understand, should I name it? Okay, I will name it. I will take this name as A, I will take this point as B, I will take this point as C, and I will take C, D, E. Try to understand, here there are three right angle triangles who are exactly congruent. Congruent is a word in mathematics, right? Not similar, exactly same size, same angle, same size, same shape, everything. Which triangles I am talking about? Try to understand. This one triangle, this triangle, and this triangle. Understood? They all are having how much height? D by 2. It is having how much height here? D by 2. Got it? So try to understand this angle. If I take this angle as theta, this angle is also theta, and this angle is also theta. Understood? So they are exactly same. So how I can write this? Let me think. This length will be how much? D by 2. Now this D by 2 length is getting divided into three parts. This part, and this part. Three equal parts. Got it? So this will become what? 1/3 of this. So this will be D by 6. This will also become D by 6. And this will also become D by 6. Now it is very easy. If I take this length as X, this will also become X. Okay? And this will also become what? X. Got it? So how much is the distance here? I will solve it here for the better visibility. So distance will be 3 times of X. X plus X plus X. Understood? For the better visibility, I can write it here 3x. Got it? Now 3x, what is x here? X is going to be square of this plus square of this by Pythagoras theorem. So this will become what? 3 times of this plus this. So square d by 6 square plus d by 2 square. So this will become d 1 by 36 plus 1 by 4. We can solve it further. Let's check. This will be 36. 1 plus 9. 4 9s are 36. So whatever you are getting here, it will be 3d. 36 will come out as 6 and this will be root 10. 3 2s are 6. So this is the answer you are getting. So root 10 upon 2 into d. This is the distance. This is the distance covered. Now another thing, sir, what is the displacement? Very easy. This is the displacement. Okay, how much it will be? D by 2 square plus d by 2 square. Understood? Okay, so this will be how much? D by 2 square plus d by 2 square. So this will become 2 times of d by 2. So d by 2 root 2. So this will be d by root 2. If I cancel it like this. Understood? So this is one of the complex question. I hope you have understood each and everything about distance and displacement, translational motion, what is the trajectory equation, okay, what is the difference between distance and displacement, what kind of questions are asked, okay, what kind of question can be asked in competitive exam. I try to cover each and everything in this lecture. So this is from my side. My name is Manpreet Singh. Thank you very much.